Hello everyone, and welcome back to the math. In this video, we are going to learn about quadratic inequalities. If you haven't watched previous videos regarding quadratics, I'll leave a link of the playlist on the top right. So quadratic inequalities are a bit different than linear inequalities that you learned before. Let's try to refresh a bit on what linear inequalities are. So the first problem that we're going to refresh is this one. This one is actually quite easy, as you know. We can try to divide both sides by 3. So we have x plus 5 is bigger than 4. So we know that x is greater than negative 1. The second problem is this. And again, we can try to divide both sides by -2. But remember, if we divide by a negative number, the sign will be flipped. After this, we can try to do some simple algebra, and we know that the solution, x is less than or equal to -2. Now let's try to see what quadratic inequalities will look like. So we're going to use a direct example. The first step that we need to do is factorize. So we can try to factorize this as usual. And then the next step, we need to draw a number line. Now this is the part where it gets complicated. So we need to draw a number line separated by the roots. So it's going to look like this. So the root is going to be 1 and 2, and then we draw a number line. Now, as you can see, the dot in the root is actually a hollow dot. This is no coincidence. This is actually a rule that we impose when we are drawing number line. Because as you can see in the inequality, the sign is actually only bigger than. There is no equal sign. If there is no equal sign, then you have to use a hollow dot. If there is an equal sign, you need to use a filled dot, like we will see in the next example. But for now, we use a hollow dot, okay? After we try to draw the number line, we shall try to divide the number line into 3 regions. So the first region is going to be when x is less than 1. Second region, x is between 1 and 2. Third region, when x is greater than 2. After this, we can try to test the regions. Again, if we take a look at the expression in the yellow box, we want to know the x such that the multiplication results in a positive number. And we want to know whether each region satisfies this inequality. So let's try to take a look at the first region. We should test x equals to 0. So if x is equal to 0, if we input it into the expression, we know that we will have 2. So 2 is actually greater than 0. So that means region 1 will always have a positive value. You can also try this with other number. Let's say x is equal to -1, and you will get the same conclusion that the multiplication is going to be a positive in the first region. In the second region, it's a bit different. So now you need to use x value in the second region, let's say 1.5. If you use x equals to 1.5 and then you input it in the expression of the left, you get minus 0.25. And as you can see, it's less than 0. You can also try other values of x in this region, and you will get the same conclusion that whatever number you choose, region 2 will always yield a negative multiplication result. So the multiplication will result in a negative number, not positive. In the last region, let's say you use x equals to 3. If you input it to the expression on the left, you get 2. 2 is greater than 0. And you can also try with other x value. Let's say you try x equals to 4 or x equals to 5, and you will still get the same conclusion that the multiplication result in region 3 is always positive. So in this case, we know that we have to test the numbers in each region. After testing, we can try to update the number line. So we try to update the number line like this. So we know that the multiplication result in region 1 is always positive, right? So we can try to write a positive sign. And then for region 2, it's always negative. So we can write the negative sign. For region 3, it's always positive. So we can write the positive sign. The next thing is, again, we have to focus on the expression in the yellow box. We want to find the x value such that the product or the multiplication is positive, bigger than 0. And we know that this is only for the region 1 and region 3. Region 2 didn't pass this test. because it's going to be negative, right? So we have to state the range that satisfies the expression, which is the region 1 and region 3. So the range for region 1 is x less than 1, and the region 3 will have a range of x bigger than 2. So the result, x less than 1 or x bigger than 2. And as you can see, since there is no equal sign, x equals to 1 and x equals to 2 are not included. Okay, next example. So in this one, we're going to do it in a similar manner. So first we try to factorize, and then we try to draw a number line. Now remember that we have an equal sign, so we are going to use a filled dot. Remember, we have an equal sign, so equal sign equals to filled dot. After this, we can try to separate the number line into 3 regions, like this. And then we can try to test each region, okay? So for the first region, let's say we use x equals to -2, and a bit of a tip, you can try to use x value that are near the roots, or you can try to use x values that makes it easier to calculate. So let's try to get back to the first region. If x is -2, that means the multiplication on the left part of the inequality is going to be 10, and 10 is greater than 0. So you can say that whatever x value, as long as it is in the first region, it will have a positive result. For the next region, I will use x equals to 0 since this is the easiest one to calculate. And we know that the multiplication is going to be -8. So we know that whatever x value, as long as it is in the second region, it's going to yield a negative value. The last region, the third one, let's say x equals to 9. If we try to multiply it, we have 10. 10 is greater than 0. So whatever x value you use in the third region, it will be positive. After testing each region, now we can try to update the number line. So the first region, positive, second region, negative, and third region, positive. And again, we need to take a look back at the expression on the yellow box. So we want to find x such that the multiplication is going to be less than or equal to 0, which means we want the x such that the multiplication will yield a negative result. So therefore, we know that the only region that satisfies this is region 2. And we have to state the range of the region 2 because it's the one that satisfies the expression. So the solution is going to be -1 less than or equal to x and x less than or equal to 8. And as you can see, -1 and 8 are included because there is an equal sign in the problem. Now, this one is going to be a bit different than the one before because, as you can see, the coefficient of x squared is negative. But the first step that we need to do is we need to make it such that the coefficient of x squared is positive. We can try to multiply both sides by -1, and it's going to look like this. After this, we can try to factorize it as usual, and then we can try to draw our number line. And again, remember that we have an equal sign, so equal sign means filled dot. That means the number line should look like this. The next step, as you know, we are going to divide the number line into 3 regions, and the 3 regions should look like this. Now, the next step, we are going to test each region. So for the first region, let's say that x is equal to -6. If we try to input it into the expression on the left, we are going to get 5. And again, whatever x value that you use, as long as it is in the first region, region 1 will be positive. Region 1 will always have a positive multiplication result. For region 2, you can try x equals to -4. And if you try to input it into the expression, you get -3. And then -3 is a negative. So whatever x value, as long as it is in the second region, it's going to be negative. And in the third region, let's just use x equals to 0. And if we try to input it, we get a positive result. So region 3 will always be positive. After testing out the regions, we can try to update the number line. So the region 1 is going to be positive, region 2 negative, and region 3 positive. Now the next question is, which sign should we use? The one on the top or the one on the bottom? So remember that we need to focus on the sign of the final expression. It's only the final expression, not the initial expression. Okay? So the final expression said to us that we need to find x such that the multiplication is positive. And the regions that passes this test is going to be region 1 and region 3. So we have to state the range that satisfy the expression, which is going to be x less than or equal to -5 or x bigger than or equal to -1. And again, x equals to -5 and -1 are included because there is an equal sign. So these are the exercise that I've prepared for you guys. I hope you can try to work on this one so that you can be more familiar on how to solve quadratic inequalities. So that's it for this video. In this video, we learned about quadratic inequalities. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.